Welcome to The Explainer. Today, we're going to tackle something really cool in the world of AI, how a general, know-it-all AI gets a PhD and becomes a real specialist. So let's just jump right in. How do you actually teach an AI to be a doctor? Or a lawyer? I mean, really? A financial analyst? You don't start from zero and build a whole new AI. No. The secret is taking an already brilliant generalist AI and putting it through a super specialized, intense training program.
Right. So we're talking about this transformation from a generalist to a specialist. Think about the big AI models you hear about all the time, like GPT-4. They're kind of like super smart college grads. They've read, basically the entire internet, so they've got this huge, broad knowledge base. They can talk about almost anything. But here's the thing. When the stakes are really high, you don't want a generalist. If you need a medical diagnosis or a legal contract analyzed, you need a specialist, right? You need an expert who gets all the jargon, all the tiny details and nuances of that specific world.
And that, right there, is where fine-tuning comes in. It's literally the AI equivalent of a PhD program. We take that brilliant grad and enroll them in a super-focused post-grad course. This is how we transform them into a genuine world-class expert.
Okay, so what is fine-tuning, really? Let's get into the nitty-gritty of this AI's postgraduate curriculum and see how it stacks up against other ways of teaching an AI.
At its core, it's pretty simple. You take a model that's already learned the basics of language, grammar, context, all that stuff from being trained on huge amounts of data. And then you just keep training it. But this time, you use a much smaller, very specific data set. This is what adapts its general knowledge to the unique language and patterns of a whole new field.
And this table really highlights the difference, doesn't it? Pre-training is the big, expensive, time-consuming university degree. We're talking months, maybe longer, feeding it the entire internet. But fine-tuning, that's the PhD. It's way faster, way cheaper, and you're just giving it a specific, curated set of textbooks to study to become an expert.
Now, it's important to know that fine-tuning isn't the only game in town. There's another really popular method called Retrieval Augmented Generation, or RAG for short. The best way to think about RAG is like giving the AI an open book exam. When you ask it a question, it doesn't just rely on its memory. First, it goes and looks up the relevant info from a knowledge base, kind of like flipping through a textbook, and then it uses that information to answer your question. So, this brings up a super important point. You gotta pick the right tool for the job. You see this chart? It lays it out perfectly. If you just need your AI to pull in the latest, up-to-the-minute information from some external source, think a customer service bot that needs the latest shipping data, RAG is your best friend. But if you need to actually change the AI's core behavior, its style, its personality, or bake in some deep fundamental knowledge, well, that's when you have to go with fine-tuning.
All right, let's talk about the training regimen itself. What does this pipeline actually look like? Because this isn't just some random process. It's a very structured, step-by-step pipeline designed to turn that generalist into a true specialist. So we can break the whole thing down into 5 main steps. Step 1, you got to prepare the textbooks. That's all your specialized data. Step 2 is setting up the classroom, which is just the whole training environment. Then, step 3, the AI starts studying. After that, step 4, it's time for the final exams to see what it's learned. And finally, step 5, graduation day. The model is ready to be deployed out in the real world.
And believe me, each one of these steps can get pretty complex. I mean, just look at this diagram for initializing the model. That's just one piece of setting up the classroom. You have to pick the right base model, load it up, get everything configured. It's a whole process just to get it ready to learn.
Okay, but here's a big problem. Fully fine-tuning one of these giant AI models, it can be crazy expensive. We're talking a ton of time and a massive amount of computing power. So what if there was a way to do this smarter, not harder?
And there is. This is where a really clever idea called parameter-efficient fine-tuning, or PEEFT, comes in. The genius of PEEFT is that instead of trying to retrain all billion-plus parameters in the model, you freeze most of them, you lock them in place, and then you only update a tiny fraction.
Probably the most popular way to do this is a method called LoRa. That stands for low-rank adaptation. And the analogy here is just perfect. Instead of rewriting an entire textbook just to add a few new facts, LoRa is like sticking a bunch of little highly specialized sticky notes on the pages. It's just a much more efficient way to add new knowledge.
And this image here really shows you the magic behind it. On the left, you've got regular fine-tuning. You have to update that entire massive block of weights. But look at LoRa on the right. The big original model is frozen. See, it's locked. And you only have to train those 2 much smaller adapter matrices, A and B.
They work together to create a small update, a little patch, that gives you almost the same result, but with a tiny, tiny fraction of the work. It's brilliant.
So, what happens after graduation? Well, these new AI specialists are already out there in the world, and honestly, they're starting to change everything.
And the journey to get here has been incredibly fast. Just look at this timeline. You can see how things really took off after 2017 with the invention of the transformer architecture. That one breakthrough basically opened the floodgates and led directly to the powerful models like GPT that we have today. The pace is just staggering.
And today's class of graduates, they are seriously impressive. You've got MedPalm 2, an AI fine-tuned for medicine that can answer questions at an expert human level. You've got FinGPT for finance, which can sift through news and data to analyze market trends. There are even specialized AIs for really complex areas like law and pharma. It's amazing.
But, of course, it's not all smooth sailing. This is really just the beginning, and there are some huge challenges we still need to figure out. How do we deal with the massive cost of scaling these things up? What about data privacy, which is a huge concern? And maybe most importantly, how do we make absolutely sure these AIs are fair, that they're not biased, and that they're accountable for their decisions?
And that leaves us with a pretty big and maybe even a little provocative question to think about. As we get better and better at creating these AI specialists, what does that mean for us, for human experts? In the future, who are we going to consider the real experts of tomorrow? Humans or the AIs we've trained? Something to chew on. Thanks for joining me on this explainer.